Hey everyone, so today we're going to start our new unit on equations, and the first thing that we need to learn how to do is how to solve one-step equations. So let's get started. So we're going to start with some mental math, kind of just figuring things out in our head, using our skills from elementary school and middle school. So we want to try to fill in the blank to make the following correct. So in your head, what plus 2 would give us 9? What do we think? What plus 2 would give us 9? Hopefully by now you figured out 7 in your head. 7 plus 2 gives us 9. Let's go to the next one. What minus 5 would give us 10? So what number minus 5 would give us 10? Hopefully you figured out the answer to that is 15. 15 minus 5 gives us 10. Okay, the next one we have parentheses here, so we know we're talking about multiplication. So 4 times what number would give us 12? Think about your 4 times tables. 4 times what number would give us 12? Hopefully you've realized that the answer to that is 3. And now here we have a fraction, so that represents division. What number divided by 2 would give us 3? So think about your 3 times tables. What number divided by 2 would give us 3? And hopefully you figured out that that's 6. So this is just some mental math, and if you were able to do this, you were able to do one-step equations. This is basically connected to what we're going to be doing, and I'm going to explain how. So for this first one, what number plus 2 gives us 9? Hopefully in your head you took the number 9 and you subtracted 2 to figure out that that was going to be 7, because 7 plus 2 would give us 9. Same thing with this one. What number minus 5 gives us 10? Hopefully you took that 5 mentally in your head, maybe without even noticing. You added it to the 10 and said, oh, that's 15, because 15 minus 5 gives me 10. Same thing with the multiplication. Hopefully, maybe not even noticing, you took that 12 and divided it by 4 and realized that the answer to that was 3. And then the same thing over here. This division, we didn't know what that number was. Maybe you multiplied 2 and 3 and got 6, and that's how you knew 6 divided by 2 is 3. So you might have done that in your head. You might not have. It might have just been obvious to you and came really quickly, but maybe subconsciously you were using inverse operations, which is what we're going to talk about in the next slide. So before we talk about inverse operations, like we said before, we're going to be solving equations. So let's define what the word equation is. An equation is a statement that the values of two math expressions are equal. Must have an equal sign. That's very important. And you can see in the word equation, it has that equa prefix there. That means equal. So it needs to have an equal sign. Unlike what we were working with before, where there were no equal signs, today and for this unit, we're going to be seeing equal signs. And when you see an equal sign, you know that you solve. You have to solve that equation and end up with a variable in the end. So an example of an equation is 3x plus 6 equals 15. So this is one math expression over here. This is another, and this is saying that these two are equal. It has an equal sign, so we know it is an equation. Now, we also need to know what inverse operations are. So an inverse operation is an operation that reverses the effect of another operation. So hopefully this sounds familiar to you. The inverse of addition is subtraction, and vice versa. The inverse of subtraction is addition. So they basically undo each other. They reverse the effect. Then the inverse of multiplication is division, and vice versa. The inverse of division is multiplication. These undo each other, and we're going to see those, see examples of those coming up. Okay, so some things that you need to know before we start solving equations is we're going to be using the word balance a lot. And basically that means what you do to one side of the equal sign, you must do to the other. So if you're going to add 2 to one side of the equal sign, you have to do it to the other. If you're going to multiply by 3, you're going to have to do that to the other side. So we have to, remember, this is an equation. They have to be equal. So what you do to one side, you have to do to the other. Treat it like a scale that you're balancing. So we need to make sure that we're doing the same thing to both sides. Okay, isolation. You might hear that word a lot in the upcoming unit. That means we need to get the variable alone. So we need to isolate the variable. We want to get it all by itself. So that also means we have to make sure that the variable is positive in the end. If you have something that says negative x equals 10, you are not complete solving this equation because this is a negative x and we need it to be positive in the end. So this is not what we want here. That means you have one more step, which we'll talk about in a little bit. Okay, so solving equations, let's get started. So when solving equations, always use inverse operations to get a variable by itself. So we're going to start by just identifying the operation that we see and then use the inverse of that operation. So for this first one, we have m plus 2 equals 9. And you're going to realize these are very similar to the ones that we did mentally. So here we see addition. So I see addition, so I have to use subtraction because that's the inverse of addition. So that's what I'm going to fill in here. So we see addition, so we have to use subtraction. We want to undo that addition. So what we do is I like to draw train tracks, and that's totally up to you if you want to. And we are going to subtract 2 here, and then we're going to do the same thing to the other side. We're going to balance. So by subtracting that 2, that's going to cancel out because 2 minus 2 gives us 0. That's the whole point of performing inverse operations, is to cancel out to get that variable by itself. So now I'm going to just bring down this m because we didn't touch the m. 9 minus 2 is 7, and then your equal sign in the middle, and that's it. So what we did was we saw addition. The opposite of addition is subtraction. You subtract the 2 on both sides, and you end up with the variable by itself. It's isolated and it's positive, so we're good to move on. Okay, the next one. We have x minus 5 equals 10. We're going to do the same thing. We see subtraction here, so we know that we're going to have to use addition, the inverse operation, to cancel that 5 out and to get x by itself. So we see subtraction. Let me just fill that in. So I have to use addition, the inverse of subtraction. So I'm going to do the same thing. I always start with my train tracks. These are helpful, especially when we have bigger equations that are more complicated to solve. Okay, so the opposite of subtracting 5 would be to add 5. What we do to one side of the equal sign, we have to do to the other to balance these. Okay, negative 5 plus 5 is 0. Those cancel out. That's exactly what we want to happen. Now I'm going to bring down my x. 10 plus 5 gives us 15. And then I'm going to bring that equal sign down. The variable is positive. It's by itself, so I know that I'm done. Okay, so we use that inverse operation to get x by itself. Let's take a look at the next one. Okay, so we have 4y equals 12. So there's nothing in between the 4 and the y, so you should know automatically that that represents multiplication. So when a variable and a coefficient and a number are written right next to each other with nothing in between, that is multiplication. So we see multiplication. I'm going to just write multiplication for now. And so we have to use division. Multiplication, division are inverse operations, so we know that we have to divide. I'm going to start by drawing my train tracks just to keep everything organized. And because we're multiplying by 4 here, we're going to divide by 4 to cancel that out. So we're going to divide by 4 on both sides. So that cancels here. Now I'm going to bring down the y. And remember, 4 divided by 4 is just 1. That's why that's able to cancel. So technically that's a 1y now on that side, but we don't have to write the 1 in. So I'm going to just bring down the y. Now 12 divided by 4, that gives us 3. So we get y equals 3. Notice how I did not put a line like I did over here. I did not put it over there because this was to show that we're subtracting. This was to show that we're adding. If we put a line here, that just might make it a little more confusing. So I'm only putting the fraction lines for this example. Okay, so we divided by 4, we got y equals 3. It's by itself, it's positive, so we know we're done. Okay, let's look at this last example. B divided by 2 equals 3. So we see division, and the inverse of division is multiplication, so that's what we're going to fill in here. We see division, so I have to use multiplication. So this one is going to look a little different than the other ones. What I'm going to do is first I'm going to draw my train tracks like always. And then I'm going to multiply this b over 2. So how I do that is I put this in parentheses, and then I show the 2 on the outside over there. So I'm going to do the same thing over here. I'm going to put the 3 in parentheses, and I'm going to put the 2 on the outside over there. So here I am going to draw a line just to separate this out. Now, 2 divided by 2, just like 4 divided by 4 was 1, 2 divided by 2 is 1. So those cancel out. Remember, that's the whole goal. We want them to cancel out. I'm going to bring down the b. And then 3 times 2 gives us 6. The b is by itself. It's positive, so we know we're done. So these are the 4 kinds of one-step equations that you're going to see. Addition, subtraction, multiplication, and division. So the way to solve these is identify what operation is being used initially, and then you're going to do the opposite of that. You're going to use the inverse operation to get the variable isolated by itself and make sure it is positive in the end.